I would say definitely Elon runs his companies in extremely unique style. I don't actually think that people appreciate how unique it is. You sort of like even read about it and so on, but you don't understand it. But it's like a very unique, different thing. Like I like to say that he runs the biggest startups.
Hey, this is Warren Redlick. A video just came out with Andrej Karpathy being interviewed by Sequoia Capital. This one from Sequoia Capital, you'll see in a minute. And he gave some really insightful answers. In particular, he said something very interesting about how Elon Musk runs his companies, how it's different.
It's like his large hammer and his willingness to exercise it within the organization.
Several points that really help distinguish what's special about Elon and the companies he runs. We're going to get into that. We're going to go through some his comments on AI and where AI is going. This is hot. This guy is one of the leaders of the AI community, so a lot to learn here. Are you ready? Let's go.
What is your view of the future over the next N years?
I think a few years ago, I sort of felt like AGI it wasn't clear how it was going to happen. It was very sort of academic, and you would like think about different approaches. And now I think it's very clear, and there's like a lot of space, and everyone is trying to fill it. So there's a lot of optimization. Everyone is trying to build what I refer to as kind of like this LLM OS. Basically, I like to think of it as an operating system. You have to get a bunch of like basically peripherals that you plug into this new CPU. The peripherals are, of course, like text, images, audio, and all the modalities. And then you have a CPU, which is the LLM transformer itself. And then it's also connected to all the software 1.0 infrastructure that we've already built up for ourselves. And so I think everyone is kind of trying to build something like that and then make it available as something that's customizable to all the different nooks and crannies of the economy.
So this is at a conference. The OS analogy, Andrej is talking about LLMs effectively becoming an operating system, just like Microsoft Windows or Apple. iOS is the operating system on your phone. Mac OS is the operating system on your computer, and then you have other software things that work with the OS. So that's a view that he thinks is popular within the AI community, and he was just at OpenAI, and I think he sees that's what OpenAI, I think he may mention this later in the talk, that is something that OpenAI is working on, is basically becoming the operating system for a world of AI. And he has a lot of interesting thoughts about AI coming up.
We can bring up and down these relatively self-contained agents that we can give high-level tasks to and specialize in various ways. So, and it's not just one agent, it's many agents. And what does that look like?
That's an important point at the end there. It's not just one agent, it's many agents. I think people have this vision that there's going to be this sort of like one large AGI controlling everything. And Karpathy talks, and if you watch the Jan LeCun interview with Lex Friedman, that's not that long ago, same idea. They seem to have the same idea that it's a better world and it's a likely world where there are multiple AIs running around rather than just one. And the idea that there's one super AI is probably not the future in the eyes of Karpathy, in the eyes of Jan LeCun, etc. So we're going to see a world of many AIs.
And if that view of the future is true, how should we all be living our lives differently?
I don't know. I guess we have to try to build it, influence it, make sure it's good, and just try to make sure it turns out well.
She kind of asked an odd question, and I don't think he really had an answer to it. His focus is really more like we should make sure that the AI is safe, is good. I think her question may have been broader than that, but I'm not sure. Like, how should we, pursue our careers, our lives, our dreams in a world with these AIs out there? And I don't think Andrej even knows the answer to that question, or if he does, maybe he just didn't understand the question.
I want to address the elephant in the room, which is that OpenAI is. Where do you think opportunities exist for other players to build new independent companies versus what areas do you think OpenAI will continue to dominate even as its ambition grows?
So my high-level impression is basically OpenAI is trying to build out this LLM OS, and it's trying to develop this platform on top of which you can position different companies in different verticals. Now, I think the OS analogy is also really interesting because when you look at something like Windows or something like that, these are also operating systems. They come with a few default apps, like a browser comes with Windows, right? You can use the Edge browser. And so I think in the same way, OpenAI or any of the other companies might come up with a few default apps, quote unquote, but that doesn't mean that you can have different browsers that are running on it, just like you can have different chat agents sort of running on that infrastructure. There will be a few default apps, but there will also be potentially a vibrant ecosystem of all kinds of apps that are fine-tuned to all the different nooks and crannies of the economy. People are trying to figure out, what is this thing good at? What is it not good at? How do I work it? How do I program with it? How do I debug it? How do I get it to perform real tasks, and what kind of oversight, because it's quite autonomous but not fully autonomous. So what does the oversight look like? What does the evaluation look like?
So you can see there, Andre, who was inside OpenAI, sees OpenAI pursuing this model with their large language model, ChatGPT, GPT-4, GPT-5, whatever, as the operating system. And maybe they'll have some apps that go along with it, but they expect there to be other apps, an app store effectively, and other ways of incorporating other companies. So there's a lot of opportunities for people to start up. But I don't think he really answered the question, because the real answer to the question would be, well, what apps are they likely to have that it doesn't make sense to compete with? His attitude was, look, Microsoft Windows comes with a browser. You can use other browsers. I have multiple browsers on my iPhone. I have multiple browsers on my MacBook, and I use more than one. I don't just use Safari. So I do think that's a fair analogy. But then there's the danger that, the ChatGPT or the OpenAI app is going to be just so much better than your app that you're going down the wrong path. So, but I don't think he necessarily has the answer to that question. He doesn't know everything that OpenAI is doing. And, what they will do in the future may change.
So the race is on right now with LLMs, OpenAI, Anthropic, Mistral, Llama, Gemini, the whole ecosystem of open source models, now a whole long tail of small models. How do you foresee the future of the ecosystem playing out?
I think the open source operating systems analogy is interesting, because we have basically an oligopoly of a few proprietary systems, like say Windows, Mac OS, etc. And then we also have Linux. And Linux has an infinity of distributions. And so I think maybe it's going to look something like that. I also think we have to be careful with the naming, because a lot of the ones that you listed, like Llama, Mistral, and so on, I wouldn't actually say they're open source, right? And so it's kind of like tossing over a binary for like an operating system. Like you can kind of work with it, and it's useful, but it's not fully useful.
So this is an important point. I've seen Jan LeCun sell and Meta talk about how their LLM is open source. I'm not familiar with Mistral, but apparently they claim to be open source. And Andre is saying, well, they're not really open source. He wasn't asked about Grok, at least so far, in the interview. XAI has Grok, and they have open sourced, and I'm not sure whether Andre would feel that that's a true open sourcing of your LLM. But it's interesting to see that point that, what's closed and what's open isn't necessarily the stuff that's said to be open isn't as open as you might think. I'm not claiming I understand that. I think I understand this point. I don't understand in what way they're not really open, though.
There are a number of what I would say is like fully open source LLMs, Pythia models, LLM 360, Olmo, etc. So, and they're fully releasing the entire infrastructure that's required to compile the operating system, right? To train the model from the data, to gather the data, etc. When you're just given a binary, it's much better, of course, because you can fine-tune the model, which is useful. But also, I think it's subtle, but you can't fully fine-tune the model, because the more you fine-tune the model, the more it's going to start regressing on everything else. So what you actually really want to do, for example, if you want to add capability, is and not regress the other capabilities, you may want to train on some kind of like a mixture of the previous dataset distribution and the new dataset distribution, because you don't want to regress the old distribution, you just want to add knowledge. And if you're just given the weights, you can't do that, actually. You need the training loop, you need the dataset, etc. So you are actually constrained in how you can work with these models. Again, I think it's definitely helpful, but I think we need slightly better language for it almost. So there's open weights models, open source models, and then proprietary models, I guess. And that might be the ecosystem.
I'm going to say that's a little over my head, but if I've got it right, there's the true open source models where you have not only the weights, but you actually have the data sets that they were trained on all open. Then you have the open weights model where you get the weights, but you don't have how they were, what they were trained on. And then when you try to do something else with that AI, with that LLM, you're going to regress. You're not going to do as well as it did before on other things, because you don't have the previous data set to train on again. When you train with the old data, you'd like to be able to train with the old data and the new data. When you train on new data, you might lose something from the old data because you don't have the old data anymore.
Simplistically, it seems like scale is all that matters. Scale of data, scale of compute, and therefore the large research labs, large tech giants have an immense advantage today. What is your view of that? And is that all that matters? And if not, what else does?
So I would say scale is definitely number one. I do think there are details there to get right. And I think, a lot also goes into the data set preparation and so on, making it very good and clean, et cetera. That matters a lot. These are all sort of like compute efficiency gains that you can get. So there's the data, the algorithms, and then, of course, the training of the model and making it really large. So I think scale will be the primary determining factor, is like the first principal component of things, for sure. But there are many of the other things. that you need to get right. So it's almost like the scale sets some kind of a speed limit almost. You do need some of the other things, but it's like if you don't have the scale, then you fundamentally just can't train some of these massive models if you are going to be training models. If you're just going to be doing fine-tuning and so on, then I think maybe less scale is necessary, but we haven't really seen that just yet.
So this is one of the concerns that people have had is you have certain players in the market. Meta's acquired a whole bunch of NVIDIA GPUs. Microsoft has a whole bunch of compute. Google has a whole bunch of compute. Tesla has been acquiring a lot of compute. I'm not sure who else is out there and how much compute they have. And what Karpathy is saying is if you want to do new models, you want to do the training on new models, you've got this new model. You just need an incredible amount of compute and you need a lot of scale in order to be able to do that. He knows better than I do, just to be clear. I have hopes that someone's going to come up with algorithms that don't require the same scale. But I'm just hoping in the dark. That there's some 17-year-old in a basement somewhere who figures out a new way of training AI that doesn't require the same volume of data. I don't know that that's not going to come. My gut hunch is that Karpathy knows more about this than I do, and he doesn't think that's a likely outcome. At least not with what he's seeing for now.
And can you share more about some of the ingredients that you think also matter, maybe lower in priority behind scale?
You can't just train these models. If you're just given the money and the scale, it's actually still really hard to build these models. And part of it is that the infrastructure is still so new and it's still being developed and not quite there. But training these models at scale is extremely difficult and is a very complicated distributed optimization problem. And there's actually the talent for this is fairly scarce right now. And it just basically turns into this insane thing running on tens of thousands of GPUs. All of them are failing at random at different points in time. And so instrumenting that and getting that to work is actually an extremely difficult challenge. GPUs were not intended for 10,000 GPU workloads until very recently. I think a lot of the infrastructure is sort of creaking under that pressure. We need to work through that. But right now, if you're just giving someone a ton of money or a ton of scale or GPUs, it's not obvious to me that they can just produce one of these models, which is why it's not just about scale. You actually need a ton of expertise, both on the infrastructure side, the algorithm side, and then the data side, and being careful with that. So I think those are the major components.
So there's an important detail relating to Tesla in there is that just using GPUs that are designed for video, originally designed for video graphics displays on computers, is not ideal. And this is one of the signs about why Tesla's Dojo might be better in the future. And there's going to be another hint he's going to drop later. I don't think he's specifically intending to talk about Tesla on these points, but Elon has specifically said, we're not making, even the H100s and A100s that NVIDIA is making aren't really, graphics computers anymore, but they are based on that architecture where Dojo is based on a different architecture. Tesla has building its own supercomputer for AI training that is not based on graphics. It's built from the ground up. And so that may be an advantage for Tesla going forward. I think we're going to see one more advantage that Tesla is working on that maybe NVIDIA is going to be behind on long term. Although, don't underestimate NVIDIA.
What are the LLM research challenges today that keep you up at night? What do you think are immediate enough problems, but also solvable problems that we can continue to go after?
So I would say on the algorithm side, one thing I'm thinking about quite a bit is this distinct split between diffusion models and autoregressive models. They're both ways of presenting probability distributions, and it just turns out that different modalities are apparently a good fit for one of the two. I think that there's probably some space to unify them or to connect them in some way, get some best of both worlds, or sort of figure out how we can get a hybrid architecture and so on. So it's just odd to me that we have sort of two separate points in the space of models, and they're both extremely good, and it just feels wrong to me that there's nothing in between. Still a massive gap in the energetic efficiency of running all this stuff. So my brain is 20 watts, roughly. Jensen was just talking at GTC about the massive supercomputers that they're going to be building now. The numbers are in megawatts, right? And so maybe you don't need all that to run like a brain. I don't know how much you need exactly, but I think it's safe to say we're probably off by a factor of 1,000 to 1,000,000, somewhere there, in terms of the efficiency of running these models. And I think part of it is just because the computers we've designed, of course, are just not a good fit for this workload. I think NVIDIA GPUs are a good step in that direction. In terms of you need extremely high parallelism. We don't actually care about sequential computation that is sort of data dependent in some way. We just have these. We just need to blast the same algorithm across many different array elements, or something. You can think about it that way. So I would say number one is just adapting the compute architecture to the new data workflows. Number two is pushing on a few things that we're currently seeing improvements on. So number one maybe is precision. We're seeing precision come down from what originally was like 64-bit for double. We're now down to, I don't know what it is, 4, 5, 6, or even 1.58, depending on which papers you read. And so I think precision is one big lever of getting a handle on this. And then the second one, of course, is sparsity. So that's also like another big delta, I would say. Like your brain is not always fully activated. And so sparsity, I think, is another big lever. But then the last lever, I also feel like just the von Neumann architecture of like computers and how they built, where you're shuttling data in and out and doing a ton of data movement between memory and the cores that are doing all the compute. This is all broken as well, kind of, and it's not how your brain works, and that's why it's so efficient. I think it should be a very exciting time in computer architecture. I'm not a computer architect, but I think there's, it seems like we're off by a factor of 1,000 to a million, something like that. And there should be really exciting innovations there that bring that down.
Okay, so there was a lot in there. The key point that I pointed at him was when he talked about the energy efficiency, that our brains use 20 watts, and these massive training computers, which are not necessarily better than the human brain, are using megawatts, which is, a million times as much power roughly. So Elon has specifically talked about this being the challenge, the biggest challenge going forward, because as the demand for AI compute skyrockets, and I think there's a pretty broad expectation that we're going to see a tremendous amount of additional compute coming online because there's just so much AI training that's going to need to be done. That one of Tesla's focuses with Dojo is making the chips energy efficient. And then the second point, again, which we talked about before, is not going on the video architecture, but going on an architecture that's specifically dedicated to AI training. And Elon has said we're on version 1 of Dojo. We got version 1.5 coming soon. We got version 2 and version 3 in the works. Tesla is focused on that. Elon's concern was number one, that the demand for electricity is going to go up so much between these new AI server farms and EVs that there's a shortage of voltage transformers. And this is already existing in the market, but it's going to get worse. So it's hard to get enough electricity to your server farm. And my gut hunch is Tesla is probably making their own voltage transformers at this point to anticipate that problem, because Elon talked about it. My gut hunch is that's the way Tesla works. They're prepared for that. And then the second point is, after we clear the voltage transformer shortage, assuming we do, there's going to be an electricity generation shortage. What I see with these AI server farms is they're currently about 1% of US energy demand, let's say. Well, if it goes up 50x, it will be 50% of US energy demand. It will radically increase the amount of energy needed to be produced in America. And unlike EVs, which you can charge at night, the server farms are going to run all day. So there's going to be a massive shortage of electricity. And so if you have a chip that's more efficient, if you have a compute system that's more efficient per watt, because the price of electricity is probably going to be driven up effectively for these server farms, the more compute you can get out of a watt, the better. And that's a really important detail that I think that the other companies are not on as much as Tesla is, although we'll see as things play out. And then the other point about new architectures and all that, Jim Keller, who worked on the hardware 3 chip in Tesla's Model 3 and Model Y and the previous generation of hardware, he has his own company, TensTorrent, and I think he's really savvy to these kinds of issues, so he may be working on that. George Hotz has a company that's working on something called TinyGrad. They have their own like small AI compute system that they're setting up that should be able to do meaningful compute at relatively low cost. Although I'm not sure that George's is intended to be energy efficient, where it's very possible that Jim Keller has some energy efficient solutions in the works for TensTorrent. So there's a lot of innovation going on the hardware side, and those are two people who are working on it that should be interesting. I think George Hotz's goal is just reduce the cost of the chips, reduce the cost of the hardware. But Andrej's point is you need to make it better at doing this kind of compute and make it more efficient.
You've worked alongside many of the greats of our generation, Sam, Greg from OpenAI, and the rest of the OpenAI team, Elon Musk. Who here knows the joke about the rowing team, the American team versus the Japanese team? Elon shared this at our last base camp, and I think it reflects a lot of his philosophy around how he builds cultures and teams. So you have two teams. The Japanese team has 4 rowers and 1 steerer, and the American team has 4 steerers and 1 rower. And can anyone guess, when the American team loses, what do? Exactly. They fire the rower. And Elon shared this example, I think, as a reflection of how he thinks about hiring the right people, building the right teams at the right ratio. From working so closely with folks like these incredible leaders, what have you learned?
So first of all, great story about Elon telling people about this issue. And Andrej has a spectacular deep answer about how Elon runs his companies. But this is one of the things that distinguishes Elon. I think that is probably the most unappreciated in people talking about Elon is his ability to build great teams, his ability to motivate people and run things well. And another key point is, here's an Asian woman. Supposedly Elon is this right wing Nazi, right? And then here's an Asian woman speaking very positively about her experience with Elon. So let's not forget that while the media might trash Elon constantly, people who encounter him in the real world seem to have a positive impression of him usually. But let's hear what Karpathy has to say about how Elon runs companies. This is absolutely brilliant stuff.
I would say definitely Elon runs his companies in an extremely unique style. I don't actually think that people appreciate how unique it is. You sort of like even read about it and so on, but you don't understand it. It's like even hard to describe. I don't even know where to start, but it's like a very unique, different thing. Like I like to say that he runs the biggest startups. It almost feels like it's a longer sort of thing that I have to think through. But well, number one is like, so he likes very small, strong, highly technical teams. I would say at companies by default, they sort of like the teams grow and they get large. Elon was always like a force against growth. I would have to work and expend effort to hire people. I would have to like basically plead to hire people. And then the other thing is that big companies, usually you want, it's really hard to get rid of low performers. And I think Elon is very friendly to by default getting rid of low performers. So I actually had to fight for people to keep them on the team. Because he would by default want to remove people. No middle management, that is kind of like non-technical for sure. So that's number one. Number two is kind of like the vibes of how everything runs and how it feels when he sort of like walks into the office. He wants it to be a vibrant place. People are walking around, they're pacing around, they're working on exciting stuff, they're charting something, they're coding. He doesn't like stagnation. He doesn't like for it to look that way. He doesn't like large meetings. He always encourages people to like leave meetings if they're not being useful. So actually, you do see this, or it's a large meeting, and if you're not contributing and you're not learning, just walk out. And this is like fully encouraged. And I think this is something that you don't normally see.
Oh, he covered a couple of points there. The first thing that I think might surprise a lot of people is how focused Elon is on keeping teams small, being resistant to hiring. And you have like Karpathy, who is, very bright, great leader, has to push hard to get permission to hire someone. And then Elon wants to fire people. If he thinks they're underperforming, he wants to fire people, and Karpathy has to fight to keep someone on the team. That attitude keeps the company from growing too much. It keeps you from wasting too much money on people who aren't contributing, but it also makes teams more effective. If you haven't followed him yet, follow Ryan Tanaka. His YouTube channel is Neuropod. I've talked to him. I think we did a space a while ago, and he talks about how when you work on a team and you work with other great motivated people, then you end up with doing great work together. Everybody motivates each other to do great work. When you start having underperforming people on teams, they sort of demotivate everyone. What Karpathy is saying kind of gels with what I've heard Ryan Tanaka say before. Ryan was an intern at Tesla twice. And he felt that's something he saw was that putting great people together, you get great stuff. If you bring in underperforming people, it really undermines the productivity of the entire team.
So I think like vibes is like a second big lever that I think he really instills culturally. Maybe part of that also is like, I think a lot of bigger companies, they like pamper employees. I think like there's much less of that. It's like the culture of it is you're there to do your best technical work, and there's the intensity and so on.
It's not a cushy environment like some other companies provide. I don't think you're getting free massages at Elon's companies. And number two, that ability to leave a meeting if you think the meeting isn't appropriate for you or you're not contributing or whatever, that's something we've heard before. That is a well understood thing, both at SpaceX and Tesla, and probably at all of Elon's companies. Is if this meeting isn't useful to you, walk out. And that's probably driven by Elon's own experience in his life being in meetings that he thought were unproductive. But it's a brilliant thing. I know so many engineers who hate meetings, and you only want to be in a meeting if it's valuable to you or if you're contributing something of value to others. So a lot of great stuff, and do great work. That's why you're here. You're here to do great work.
Just how connected he is to the team. Usually a CEO of a company is like a remote person 5 layers up who talks to their VPs, who talk to their reports and directors, and eventually you talk to your manager. It's not how he runs companies, right? Like he will come to the office, he will talk to the engineers. Many of the meetings that we had were like 50 people in the room with Elon, and he talks directly to the engineers. He doesn't want to talk just to the VPs and the directors. Normally, people would spend like 99% of the time maybe talking to the VPs. He spends maybe 50% of the time, and he just wants to talk to the engineers. So if the team is small and strong, then engineers and the code are the source of truth. And so they have the source of truth, not some manager, and he wants to talk to them to understand the actual state of things and what should be done to improve it.
I think that's a huge point that is massively underappreciated. There's people who think that Elon just hires great people and they go and build rockets. And the reality is he's on the ground with the engineers, talking to them, figuring out what's going on, helping them solve problems. And Andrej has a great story coming up about that.
The degree to which he's connected with the team and not something remote is also unique. And also just like his large hammer and his willingness to exercise it within the organization. So maybe if he talks to the engineers and they bring up that, what's blocking you? Okay, I don't have enough GPUs to run my thing. And he's like, oh, okay. And if he hears that twice, he's going to be like, okay, this is a problem. So like, what is our timeline? And when you don't have satisfying answers, he's like, okay, I want to talk to the person in charge of the GPU cluster. And like someone dials the phone and he's just like, okay, double the cluster right now. Like let's have a meeting tomorrow. From now on, send me daily updates until the cluster is twice the size. And then they kind of like push back and they're like, okay, well, we have this procurement set up, we have this timeline, and NVIDIA says that we don't have enough GPUs and it will take 6 months or something. And then you get a rise of an eyebrow. And then he's like, okay, I want to talk to Jensen. And then he just kind of like removes bottlenecks.
So I'm going to talk to Jensen. I just love that. I wondered, all of a sudden Elon said they had an allotment of H100 GPUs coming to Tesla, and then XAI suddenly had an allotment of H100 GPUs. These are the supercomputers that NVIDIA sells that are in really high demand and really hard to get. And apparently when Elon calls Jensen Huang, the CEO of NVIDIA, and says, this is what I need, Jensen gets it to him. There was a story recently that Meta bought like 350,000 H100 GPUs. I think Mark Zuckerberg has the same phone number. And when you are the head of a high-profile company and you know what to do, you're able to go get done what needs to get done. And this is something that other CEOs wouldn't be on the ground talking to the engineers to understand the nature of the problem. And then I love, Elon has a great hammer, has a big hammer. I'm sure you can take that a lot of ways, but the fact is that when Elon decides something needs to be done, he makes it happen. If you read the biography, you can see instances in the biography where he just decides this needs to be done and they get it done. And that's probably very inspiring to be a worker on the team when you tell the boss, hey, this is what we need, and somebody else says, hey, this is what we need, and he makes it happen. He listened to you and he got done what you needed to get done so that you can do great things. That is what great management does. And it's in short supply, and Elon is a great example of it.
The extent to which he's extremely involved and removes bottlenecks and applies his hammer, I think is also not appreciated. So I think there's a lot of these kinds of aspects that are very unique, I would say, and very interesting. And honestly, going to a normal company outside of that you definitely miss aspects of that. Yeah, that's maybe that's a long rant.
So he hit on another point there, that when people leave an Elon Musk company and they go somewhere else, they often miss it. This was covered in the biography, that a couple of employees in the biography, I remember one at least, but there may have been more than one, who had left the company because they just get burned out. And then they just can't stand working anywhere else because the experience of actually getting things done and the quality of the work environment at Elon's companies is so much better. In the biography, I think the story was about SpaceX. But that ability to deliver that kind of environment that really makes engineers feel like, hey, we're really getting something done is super important. Engineers want to get stuff done. They don't just want, some engineers just want a paycheck, but a lot of engineers want to accomplish something. And if you show engineers you're committed to helping them accomplish something and clear stuff out of the way, Gwynne Shotwell just talked about this in one of my recent videos, that her job is to get things out of highly productive employees, get things off their desk so they can focus on doing great work. If people are getting bottlenecked, she wants to fix the bottlenecks. Elon wants to fix the bottlenecks. That's something that great managers do to enable their team to outperform.
As you think about the next chapter in your life, what gives you the most meaning?
You've described it in the right way, where my brain goes by default. I've worked for a few companies, but I think ultimately I care not about any one specific company. I care a lot more about the ecosystem. I want the ecosystem to be healthy. I want it to be thriving. I want it to be like a coral reef of a lot of cool, exciting startups and all the nooks and crannies of the economy. And I want the whole thing to be like this boiling soup of cool stuff. And
Genuinely, Andre dreams about coral reefs.
I want it to be like a cool place. And yeah, that's why I love startups and I love companies. And I want there to be a vibrant ecosystem of them. And by default, I would say a bit more hesitant about 5 megacorps kind of like taking over, especially with AGI being such a magnifier of power. I'm kind of worried about what that could look like and so on. So I have to think that through more. But
If you're not familiar with Andre, outside of his work at Tesla or OpenAI, one of the things he loves to do is educate people. Here's how you can do better with AI. He has done a bunch of YouTube videos, which are like, you have to watch it like 0.75x speed and watch it 2 or 3 times to try to, grab it all in. He's like, high velocity and a lot of information density in a short time. He echoes a point. Again, I think this is something that Jan LeCun kind of talks about is we don't want, and I think Elon talks about it. You don't want 5 megacorps controlling AI. And he seems to think AGI, I mean, when he talks about this, he's definitely indicating that AGI is close. It's not that far away. We're going to have AGI soon. What that means, that's an open question, but he is concerned about the future of AGI, and he wants to make sure that more and more people have access to it. Jan LeCun just talked about this. If you have a bad guy who has an AI, if we have good guys who have good guy AIs, they can protect us from the bad guy AIs. I think that's a reasonable approach. And if you just have a limited number of people controlling AI, then there's more risk that some bad AI gets control or people abuse their power with AI. And keep in mind, he was at the supposed dominant force, OpenAI, and maybe that's one of the reasons he left is he did not want to be a part of, Megacorp deploying, the great all-powerful AI that takes over the world. That's not his goal in life to be a part of that.
Would you recommend founders follow Elon's management methods, or is it kind of unique to him and you shouldn't try to copy him?
yeah, I think that's a good question. I think it's up to the DNA of the founder. Like you have to have that same kind of a DNA and that some kind of a vibe. And I think when you're hiring the team, it's really important that you're making it clear upfront that this is the kind of company that you have. And when people sign up for it, they're very happy to go along with it actually. But if you change it later, I think people are unhappy with that, and that's very messy. So as long as you do it from the start and you're consistent, I think you can run a company like that. It has its own like pros and cons as well. And I think up to the people, but I think it's a consistent model of company building and running.
I think it's an important point here. Again, somebody who's worked very closely with Elon for years seems to have a great deal of respect for Elon. Doesn't say anything negative about him. And this question was an excellent question. I agree with Andre. I think it's really hard for someone who's not Elon to run a company the way Elon does, because you basically have to commit to working 16-hour days for a decade or more. And you have to be in the trenches and you have to resist the pull that you get from the investment community, whatever. There's all this pull to raise yourself up and create these layers of bureaucracy between you and the employees, and the ability to get down and stay down in the trenches with people as much as Elon does. That's hard for a lot of people to do. And do you have the engineering chops to do it? Is it in your DNA to do that? I think it's a really good way to run companies, but you have to be the right person to do it. And I think Andre said that really well.
Do you think there's a path towards building a physicist or a von Neumann type model that has a mental model of physics that's self-consistent and can generate new ideas for how do you actually do fusion? How do you get faster than light travel, if it's even possible? Is there any path towards that, or is it like a fundamentally different vector in terms of these AI model developments?
I think it's fundamentally different in one aspect. I guess like what you're talking about maybe is just like capability question, because the current models are just like not good enough. There are big rocks to be turned here, and I think people still haven't like really seen what's possible in the space, like at all. And like roughly speaking, I think we've done step 1 of AlphaGo. This is what we've done imitation learning part. There's step 2 of AlphaGo, which is the RL. And people haven't done that yet. And I think it's going to fundamentally, like, this is the part that actually made it work and made something superhuman.
RL is reinforcement learning, sometimes paired with human feedback, which I think he's going to talk about in a minute, is not important, but reinforcement learning. AlphaGo is the system that beat the best player in the world in the game Go. And it did reinforcement learning by playing against itself, millions of times and having a reward structure so that it learned to play actually better than human, dramatically better than human.
I think there's like big rocks and capability to still be turned over here. The details of that like are kind of tricky potentially, but I think we just haven't done step 2 of AlphaGo, long story short, and we've just done imitation. And I don't think that people appreciate, like, for example, number one, like how terrible the data collection is for things like ChatGPT. Say you have a problem, like some prompt is some kind of a mathematical problem. A human comes in and gives the ideal solution, right, to that problem. The problem is that the human psychology is different from the model psychology. What's easy or hard for the human are different to what's easy or hard for the model. And so human kind of fills out some kind of a trace that like comes to the solution, but like some parts of that are trivial to the model and some parts of that are a massive leap that the model doesn't understand. And so you're kind of just like losing it, and then everything else is polluted by that later. And so like fundamentally what you need is the model needs to practice itself how to solve these problems. It needs to figure out what works for it or does not work for it. Maybe it's not very good at 4-digit addition, so it's going to fall back and use a calculator. But it needs to learn that for itself based on its own capability and its own knowledge.
Pretty interesting point that we tend to think that somehow we're training the AI, and there's some things where we say do it this way, and the AI doesn't really understand it that way. And his suggestion is the AI needs to train itself. That's the reinforcement learning. The AI needs to try to tackle that problem itself and figure out how it can do the problem best, rather than being told by humans how to do it.
It's a good initializer, though, for something agent-like. And then the other thing is, like, we're doing reinforcement learning from human feedback, but that's like a super weak form of reinforcement learning. It doesn't even count as reinforcement learning, I think. Like, what is the equivalent in AlphaGo for RLHF? It's like, what is the reward model? It's what I call it is a vibe check. Like, imagine, like, if you wanted to train like an AlphaGo RLHF, you would be giving 2 people 2 boards and like said, which one do you prefer? And then you would take those labels and you would train a model, and then you would RL against that. Well, what are the issues with that? It's like, number one, it's just vibes of the board. That's what you're training against. Number 2, if it's a reward model that's a neural net, then it's very easy to overfit to that reward model for the model you're optimizing over, and it's going to find all these spurious ways of hacking that massive model. This is a problem. AlphaGo gets around these problems because they have a very clear objective function. You can RL against it.
I think he just clarified a little bit, human feedback, human training is not ideal. And as long as you can give a clear reward function to the AI, then it can optimize based on training itself. Getting a clear reward function is challenging. I don't think that, I don't know if he's going to talk about that. I don't think he talks about that here. But how do you define a clear reward function? And if you haven't seen it, there's a documentary on AlphaGo. It's probably on YouTube. I forget, maybe it's on Netflix, whatever. But watch the documentary on AlphaGo. It's absolutely brilliant.
So RLHF is like nowhere near, I would say, RL. This is like silly. And the other thing is imitation learning, super silly. RLHF is nice improvement, but it's still silly. And I think people need to look for better ways of training these models so that it's in the loop with itself and its own psychology. And I think there will probably be unlocks in that direction.
So this point about imitation learning is also important for Tesla when you look at Tesla Optimus, and also when you look at FSD. The way the cars are being trained now, is that FSD is being trained now, is to imitate, whenever we have a problem area, let's train it on how the best drivers drive. And the reality is you'd like to get to the point where the car can train itself. How can we drive better? Or the software can train itself. How do we drive better in these circumstances? And with Optimus, there's a lot of people pumping, hey, we're going to have these humanoid robots that are going to be great at doing tasks because we'll have it imitate how human workers do tasks. But again, and I've said this a whole bunch of times, the real game with Optimus, the real game with humanoid robots is understanding the real world so that the robot can figure out for itself how to do a task that it's never seen before. That's a total game changer as compared to we're going to train it to fold a shirt. And then, if there's any kind of, any significant change in the circumstances, the robot may not be able to fold the shirt. It needs to understand the real world. And then you need some sort of scoring function and some sort of system where you can train itself, and maybe it's training humanoid robots in simulation, maybe it's training FSD in simulation, where it compares. And they actually do this with simulation at Tesla. They told us this. They take the same setting, and then they change lighting, and they change weather conditions, and they change a whole bunch of other things and train on all of that in simulation. And so reinforcement learning without human feedback is really, really valuable. But again, you need that objective function, which is tricky to work out.
So it's sort of like graduate school for AI models. It needs to sit in a room with a book and quietly question itself for a decade.
I think that would be part of it, yes. And I think like when you are learning stuff and you're going through textbooks, like there is an exercise, there's exercises in the textbook. Where are those? Those are prompts to you to exercise the material. And when you're learning material, not just like reading left to right, right? Like number one, you're exercising, but maybe you're taking notes, you're rephrasing, reframing, like you're doing a lot of manipulation of this knowledge in a way of you like learning that knowledge. And we haven't seen equivalents of that at all in LLMs. So it's like super early days, I think.
This is a point I've been actually touches on something I've been talking about a lot lately is we're talking about how to train machines to learn. I think there's a big reflection back on how we learn. And Andre kind of hinted at this, like when you're at the library, well, you do this, and then there are problems in the textbook, and that's a prompt to you. So your neural nets are being prompted. Like there's a prompt engineering going on, and you're being prompted. And I have this whole view that like pickup artists are actually prompt engineering women to get a phone number or get a date. I think there's a lot to that to really dive in to try to understand not just how to get machine learning to work, but to really understand ourselves and how do we think and how do we learn, and what data sets are we training ourselves on, and what are we curating? How are we curating the data that we feed into our neural nets? There's a whole way deep you can go here, but Andre doesn't really dive into that, so let's get back to Andre.
Optimal and practical at the same time. So I would be asking, like, how would you be align the priority of like either doing cost reduction and revenue generation, or B, like finding the better quality models with like better reasoning capabilities? How would you be aligning that?
So maybe I understand the question. I think what I see a lot of people do is they start out with the most capable model that doesn't matter what the cost is. So you use GPT-4, you super prompt it, etc. You do reg, etc. So you're just trying to get your thing to work. So you're going after sort of accuracy first, and then you make concessions later. You check if you can fall back to 3.5 for certain types of queries. You check if you and you sort of make it cheaper later. So I would say go after performance first, and then you make it cheaper later. It's kind of like the paradigm that I've seen a few people that I've talked to about this kind of say works for them. And maybe it's not even just a single prompt. I'll like think about what are the ways in which you can even just make it work at all. Because if you just can make it work at all, like say you make 10 prompts or 20 prompts and you pick the best one and you have some debate, or I don't know what kind of a crazy flow you can come up with, right? Like just get your thing to work really well. Because if you have a thing that works really well, then one other thing you can do is you can distill that, right? So you can get a large distribution of possible problem types. You run your super expensive thing on it to get your labels, and then you get a smaller, cheaper thing that you fine tune on it. And so I would say I would always go after sort of get it to work as well as possible, no matter what first, and then make it cheaper is the thing I would suggest.
So I'm not going to claim I fully understand that.
So this past year, we saw a lot of kind of impressive results from the open source ecosystem. I'm curious what your opinion is of how that will continue to keep pace or not keep pace with closed source development as the models continue to improve and scale.
I don't really know. Fundamentally, like these models are so capital intensive, right? Like one thing that is really interesting is, for example, you have Facebook and Meta and so on who can afford to train these models at scale, but then it's also not it's not the thing that they do, and it's not involved, like their money printer is unrelated to that. And so they have actual incentive to potentially release some of these models so that they empower the ecosystem as a whole so they can actually borrow all the best ideas. So that to me makes sense. But so far, I would say they've only just done the open weights model. And so I think they should actually go further, and that's what I would hope to see. And I think it would be better for everyone. And I think potentially maybe they're squeamish about some of the aspects of it eventually with respect to data and so on. I don't know how to overcome that. Maybe they should like try to just find data sources that they think are, very easy to use or something like that, and try to constrain themselves to those. So I would say like those are kind of our champions potentially, and that's I would like to see more transparency also coming from, and I think Meta and Facebook are doing pretty well. Like they've released papers, they published a logbook, and they're doing. I think they're doing well, but they could do much better in terms of fostering the ecosystem, and I think maybe that's coming. We'll see.
The point there is, I think that Facebook Meta can't release the data because the data that they're using has probably got some privacy component to it. That they're using, data that you and I generate if we're using Facebook or Instagram or WhatsApp or whatever, and if they release that data, then they might be releasing our private information. They're open, but they're not as open as you might like them to be, as Andre would like them to be, but he understands, hey, maybe they just can't release that data.
What do you think would make the AI ecosystem cooler and more vibrant, or what's holding it back? Is it, openness, or do you think there's other stuff that is also like a big thing that you'd want to work on?
Yeah, I certainly think like one big aspect of is just like the stuff that's available. I had a tweet recently about like number one, build the thing. Number two, build the ramp. I would say there's a lot of people building a thing. I would say there's a lot less happening of like building the ramps so that people can actually understand all this stuff. And I think we're all new to all of this. We're all trying to understand how it works. We all need to like ramp up and collaborate to some extent to even figure out how to use this effectively. So I would love for people to be a lot more open with respect to what they've learned, how they've trained all this, what works, what doesn't work for them, etc. Yes, just from us to like learn a lot more from each other. That's number one. And then number two, I also think like there is quite a bit of momentum in the open ecosystems as well. So I think that's already good to see, and maybe there's some opportunities for improvement I talked about already.
Ramps, I think he's not referring to ramping to produce at scale. He's referring to ramps to give other people access to understanding what's going on. And that's, I think, what Andrej is working on himself is he wants to do videos and other things to train people to have better access to AI tools, understand how to do things in the AI world.
To get to like the next big performance leap from models, do you think that it's sufficient to modify the transformer architecture with, say, thought tokens or activation beacons, or do we need to throw that out entirely and come up with a new fundamental building block to take us to the next big step forward or AGI?
Mm-hmm. Well, the first thing I would say is like Transformer is amazing. It's just like so incredible. I don't think I would have seen that coming for sure. Like for a while before the Transformer arrived, I thought there would be an insane diversification of neural networks. And that was not the case. It's like complete opposite, actually. It's a complete, it's like all the same model, actually. So it's incredible to me that we have that. I don't know that it's like the final neural network. I think there will definitely be. I would say it's really hard to say that, given the history of the field, and I've been in it for a while, it's really hard to say that this is like the end of it. Absolutely, it's not. And I think I feel very optimistic that someone will be able to find a pretty big change to how we do things today. I would say on the front of the autoregressive or diffusion, which is kind of like the modeling and the loss setup, I would say there's definitely some fruit there probably. But also on the transformer, and like I mentioned, these levers of precision and sparsity, and as we drive that, and together with the co-design of the hardware and how that might evolve, and just making network architectures that are a lot more sort of well-tuned to those constraints and how all that works. To some extent, also, I would say like Transformer is kind of designed for the GPU, by the way. Like that was the big leap, I would say, in the Transformer paper, and that's where they were coming from, is we want an architecture that is fundamentally extremely parallelizable. And because the recurrent neural network has sequential dependencies, terrible for GPU. Transformer basically broke that through the attention, and this was like the major sort of insight there. And it has some predecessors of insights like the neural GPU and other papers at Google that are sort of thinking about this, but that is a way of targeting the algorithm to the hardware that you have available. So I would say that's kind of like in that same spirit. But long story short, like I think it's very likely we'll see changes to it still.
So again, a little bit over my head here, but transformers is a fundamental technology that enables neural networks, and it's a technology that works on GPUs. And like I said, I think Dojo is working on how do we use transformers more efficiently than GPUs currently use them. Others are probably working on something similar, but Karpathy's point is, hey, there might be something better than transformers coming along. He thinks it's likely that something will come along, but he doesn't see it. I'm not saying it's not going to happen. He just, what it's going to be, he doesn't know. We don't know. Very exciting future.
But it's been proven like remarkably resilient. I have to say, like it came out many years ago now. Like the original Transformer and what we're using today are like not super different.
As a parting message to all the founders and builders in the audience, what advice would you give them as they dedicate the rest of their lives to helping shape the future of AI?
Yeah, I don't usually have crazy generic advice. I think like maybe the thing that's top of my mind is, I think founders of course care a lot about like their startup. I also want, like, how do we have a vibrant ecosystem of startups? How do startups continue to win, especially with respect to like big tech? And how does the ecosystem become healthier, and what can you do?
Not so much about here's how to be successful with your company, but hey, make sure your work is helping build the ecosystem that allows everyone to participate in the development of AI rather than just big tech controlling it or your company getting control of it. Make sure that you're helping other people participate as well.